Hello and welcome to Mr. Davis's classroom. Today we're going to be taking notes on lesson 4.2 of our Algebra 2 books, which is standard form of a quadratic function. This is found on pages 202 to 207. And let's get into it. There we go. Alright, standard form is different than Vertex form. Remember, Vertex form we learned about in lesson 4.1, and its form was f of x is equal to a parentheses x minus h squared plus k. Now, obviously, there's some visual differences here right away. Standard form is written out with no parentheses, and they use a little bit different letters with the exception of a. The pros to standard form is it's easier to enter into a calculator and computers, which nowadays is a very helpful tool. It's also prettier. Most people would agree that this is a easier looking formula. And it's easier to do math with, which means you don't have parentheses to get rid of before you plug in any values or anything like that. The cons is the information is hidden. And if we remember in Vertex form here, in Vertex form, the information was given straight to us, right? HK is our vertex. A is our compression or our stretching. So it's still there, but it's hidden. We need to look for it and do some math to figure it out. All right, so problem one. Problem one, finding the features of a quadratic function. What is it? The vertex, axis of symmetry, maximum or minimum value, and the range of this formula here. Well, what we can do is do this with graphing, because we really have no other tools right now than a graphing calculator. So I'm going to bring up my graphing calculator right now, right here, and I'm going to bring up my, type in the equation as it was written, which was 2x squared plus 8x minus 2. And I'm going to double check that just to make sure I wrote it down right. 2x squared plus 8x minus 2. Alright, so what I'm going to do is I'm going to hit enter on this, and it gives me my graph right there. And from this, we can use a calculator to find some of these pieces of information. For example, what I'm going to do first is, dragging down here, is I'm going to try to find this point right here, which is the minimum, right? We have a minimum here. So I'm going to try to find the minimum. So I'm going to go to the menu button, and we're going to analyze the graph, and we're going to find the minimum. And it comes up with these dotted lines, and we need to sandwich that minimum. It's going to tell us right there, the minimum is at -2, -10. So that's not only the minimum, but that's the vertex right there, the minimum vertex. So let's write that down on our board here. Vertex, and the vertex actually helps us by telling us much of the information. So vertex was -2, -10. Alright, so that is vertex. Alright, so that's vertex. Right, got that done. Axis of symmetry. Now remember, the axis of symmetry is where we can fold the graph and have it be equal on both sides. So, and it's always going to be an x equals equation because it's a vertical line. And it's always going to be the x value of the vertex. So it's x is equal to -2. And this is our axis of symmetry. So now we have that part done. The next is the maximum or minimum value. Well, again, that's found in the vertex. And it's a minimum because we had a upward facing parabola. So our minimum value is where y is equal to -10. That's our minimum. So we have that done now. And last is the range. Well, since it's a minimum, -10 is going to be our smallest value. And our biggest value, well, these go on forever in the positive direction. So this is our range. And again, did they ask us the domain? No, because in these, the domain is always going to be all real numbers. So really, the range is the only one that's going to vary from problem to problem. Okay. So we just used a graphing calculator to help us solve this. Now, that's something we could do with many types of equations that we don't know how to do by hand. Right? We use a graphing calculator. You'll see here, it says like problems 8 through 16. That's going to be in your homework, so I mean, this is something to refer to. And that's it. That's, I mean, not too bad. So let's move forward. We're going to talk some properties of standard form. First off, the A value. Right? We notice that there's an A value in both the standard form and the vertex form. And the A value does exactly the same thing as in vertex form. It tells us whether it's facing up, down, or is it a stretch, or a compression. Right. Exactly the same thing. So what vertex form told us where what the A value is, and then it also told us where the vertex is. Now this is where the hidden information comes in, because the vertex we have to do some math with. Instead of just looking at it and picking it out of the equation, the form, what we have to do is we have to do a little bit of math. First off, the x value of the vertex. Remember, the vertex is going to have an x, y coordinates. The x value is going to be found with that equation there, which is opposite of b over 2a. So that's how you can find the x coordinates. So that's going to go right here with the x. Once we have that number, it can be any number. It could be a number like 2 or 10 or 0 or 1.1. But once we have that number, we need to plug it in to the input, which means we need to put it into the equation and get a y value out. And that y value will be here. So there's some math that's belonged with it. And that's the downfall to the standard form. That's the con to the standard form. But there are some upsides to it too. And then the c value is going to be the y-intercept. Right? So that's one piece of information that tells us that we didn't get from the vertex form. So c value is the y-intercept, which is where this is going to cross the y-axis. And it will always cross the y-axis. All right. So knowing those pieces of information, let's look at graphing a function in standard form. And this is like problem 17 through 25 in your homework. So there's some steps here we have. First one is to identify a, b, and c. Well, my a value is always found with my x squared, and it's 1, so we have 1x squared. My b value is 2, and our c value is 3. Step 2 is to find the axis of symmetry. Remember, the axis of symmetry and the vertex is found with the equation opposite of b over 2a, where opposite of b is negative 2 over 2 times a, which is 2 times 1, which is 2. If we reduce that, we get negative 1. So negative 1 is the x coordinate to our vertex. So what I'm going to do is with, let's say, red, I'm going to draw on my axis of symmetry, which means right there, that's where it's going to be symmetrical. Then let's find out what the vertex is. The vertex has to be on the dotted line somewhere. We know that the first point is negative 1. Second point is going to be if I plug negative 1 into this equation. So I'm going to have y is equal to negative 1 squared plus 2 times the negative 1 plus 3. This is y is equal to 1 minus 2 plus 3, which is y is equal to 2. So our vertex is at negative 1, 2, which is right there. That's our vertex, negative 1, 2. So that's step 3. We've done steps 1, 2, and 3. Step 4 is to find the C value. Now, the C value, remember, is important because it's the y-intercept. So our C value is a positive 3, which means it's going to cross the y-axis at a positive 3. Now, here's where standard form gets to be pretty nice because these are symmetrical. I know that that point is also going to be on the line. See how it's 1 over and 1 up, 1 over and 1 up from the vertex. So 1 over and 1 up. So it's symmetrical. And again, remember I said the A value works the same. So when I draw the curve, I know the A value is 1, which means I'm going to be doing squares here. So if I go over 1, I go up 1 squared, which is 1. If I go over 2, I go up 2 squared, which is 1, 2, 3, 4. And I need to draw that curve like that. Now that's a beautiful looking curve and everything. I'm sure you guys can draw better. So that's graphing in standard form, right? It's not too much more difficult. The only different part is steps 2 and 3 where we have to actually solve for them first. All right. Problem 3 is converting from standard to vertex, okay? If you really, really like vertex form and that's the way you want to graph it, you can convert them to vertex form. These are going to be like problems 26 through 31, so we're going to have a little bit of practice at that. All right. We want to convert this to vertex form. Remember, vertex form is going to be y is equal to a x minus h squared plus k. All right. So the first thing we want to do is we want to factor out our a value. See how the a value here is factored out? And this is our a value. So I need to have 2 on the outside of some parentheses. Right? So that's going to be plus 5x. And I'm going to keep this 7 on the outside. Okay. Then what we want to do is we want to change it to this form here, right? So now that we know where the A value is, we want to come up with what's going to need to go here for H and K. Well, that is just the vertex. Vertex is HK. Well, we can find HK by using our formula. Just opposite of B over 2A. Opposite of B over 2A. Well, opposite of B, well, B was 10, so that's negative 10 over 2 times A, which is 2 times 2, which is 4, which is going to give us a negative 2.5, which is my H value. To find K, we need to plug that negative 2.5 in. So we're going to have Y is equal to 2 times negative 2.5 squared plus 10 times negative 2.5 plus 7. All right. This is going to be Y is equal to 2 times 6.25 plus, so I guess that's going to be a negative 25 plus 7, which is going to be Y is equal to 12.5 plus negative 20, it's negative 25 plus 7, which if I do my math there, it looks like it's going to be a negative 5.5, which is my K value. Alright, I'm going to clear some room here. Kind of made a mess right there, so let's clean that up. And we have our A value, which stays the same, so I'm going to have 2. A value stays the same. H, or X minus H was negative 2.5, so that's going to be plus 2.5 squared plus k. Well, k was a negative 5.5, so I'm just going to write minus 5.5. And this is our vertex form. Okay? So basically, steps in doing this, right? We know a value. To find h value, we need to use the formula, and then we plug it in to find k value. Here we have a picture of a New River Gorge Bridge, which I have a picture here, which is in West Virginia. It's the world's largest steel single arch bridge. I see there it looks pretty tall. We have some rafters down there. So it looks pretty tall. It's 516 feet to the bottom of the arch. We want to know a few things. One is, how high is the river, how high above the river is the arch? Right? So we're talking about this 516 plus the height of the arch. And then how long is a section of bridge above the arch, which means in this yellow box here, how long is that top part of that box? They gave us an equation. It's in standard form. There is no C value. Well, there is a C value. That C value is 0. We don't need to write it down because of, it doesn't change anything mathematically. So first things that we want to do here is we want to try to change this into something a little bit more nice for us to look at. All right, so what I'm going to do is I'm going to take, and since the C value out here was 0, it means that the y-intercept is at 0, which tells me that if I look at this arch of the bridge as my graph, that is going to be my xy coordinates. How do I know? Because my y-intercept is at 0. So it needs to start at 0, 0. And then it goes up and then back down again. All right? So first off, let's figure out how high is this arch. Well, the tallest part of this arch is going to be right here, which is the vertex. Vertexes are pretty important. So vertex. All right. So we need to find that vertex. We can find that with, by knowing that x is going to be equal to opposite of b over 2a. It's pretty important. Opposite of b is going to be a negative 0.847 over 2 times a. Well, 2 times a, it's time for us to pull out the calculators. 2 times a, let's see. Calculator working. There we go. All right, 2 times a, well, we have 2 times negative 0.000498. You guys can do this too to see that that will equal negative 0.000996. Yeah, it looks like with these decimals, it looks like it's definitely calculator work here. So now I'm going to make a fraction and do negative 0.847 on top. On bottom, negative 0.000996. And we get, for x, 850.4. So that means 850 feet, 0.4, 850.4 feet. Now what does that tell us? It tells us that's the x value, right? So that's not the height, that is this way. So it's that bridge to the middle of it is 850 feet to the middle. How tall is that bridge though? That's the y value, right? So we need to plug that in. So we need to plug in 850 into our equation here. So we're going to do y is equal to negative 0.000498 850.4 squared plus 0.847 times 850.4. And that should give us the y value, which is going to be the height. All right, so I'm going to plug this into a calculator. Negative 0.000498 times 850.4. I'm just doing this on my calculator really quickly. Plus 0.847 times 850.4. And we get y is equal to 360.145. Now, 0.145 of a foot is, maybe an inch and a half or 2 inches. Not much at all. So let's see what we have here now and try to clean this up as much as possible. So we have x is 850 and y is 360, and I'm of course rounding here. So I'm going to write those down as my vertex and clean everything else up. I'm going to clean up all my work so it looks nice and neat and tidy. So we're at 850, 360. So that tells us that the height of the arch is 360 feet. But is that how far it is above the water? No, because the bridge is already 516 feet high. So if I do 516 plus 360, I'm going to get 876 feet. That's about 876 feet high. And if you Google this bridge, you'll actually see a lot of people doing bungee jumping and paragliding down off of it because it's so high. So that's this problem right here. That's that first part. How high is the river above at the highest point of the arch? 876 feet. How long is the section of bridge above the arch? Now what we want to know is how long is it from right here to right here, right? Just above that arch part. Well, there's a few ways we could try to do this. One is we could try to find the coordinates of this point right there, right? Coordinates of that point right there, and that'd tell us the x value, right? And we could do that because of we know the y value would be at 0, and we could plug in 0 here for y, and then solve for x. That actually turns out to be slightly difficult. What we can do is we can kind of use our intuition, and we could say from the starting point to the vertex is halfway, right? So let's say from the starting point to the vertex is halfway across the bridge. Well, halfway across the bridge, I've gone 850 feet. How far is that other half going to be? The other half is also going to be 850 feet. So I'm going to have 850 on both sides of the vertex. 850 plus 850 is 1,700 feet. So the length, what did I say, 1,700? 1,700 feet. Now, I know some of you guys will be saying, hey, you dropped off 0.4 feet on each side, which is going to actually round up to 1,701 feet. But I think 1,700 sounds much more nice. It rolls off the tongue much better. So those of you that knew that it was supposed to be 1,701, congratulations for being accurate. But we'll just call it 17 for simplicity's sake. Okay. Your homework today is on page 206. It's 1931 odd and 33 through 47 all. That second part is all. So I don't have to answer that question. It is all of them. And that's our lesson for today.